So welcome everyone. Welcome to the session on a talk on Maimon titled Ampliative Analysis in Maimon's Thought. Before introducing speakers, I'd like to mention some practical matters. And in particular, I'd like to ask you if you could switch on your camera, if at all possible, so that everyone can see each other. And I also wanted to mention that normally after the session, we leave open the Zoom meeting so that everyone who's interested can hang on and have some more informal conversations. So let me now welcome and introduce our speakers. I'm very pleased to introduce Idit Chikurel. She obtained her PhD in Tel Aviv in 2019. And since then, she has held various postdoc positions, including positions at the University of Potsdam and the Humboldt University. She's currently Minerva postdoctoral fellow at the Munich Center for Mathematical Philosophy, also at the University of Munich. She's the author of a monograph titled Salomon Maimon's Theory of Invention, Scientific Genius Analysis, and Euclidean geometry, published with de Gruyter in 2020. Yes, and I think that the talk today is related to the topic of this monograph. Idit also published various articles on Maimon, including one titled Analysis and Necessity in Arithmetic in light of Maimon's concept of number as ratio. And this one was recently published in Kantstudien, so in earlier this year, in 2023. Idit's talk will be followed by a response from Caterina Marinelli, and she's currently a postdoctoral researcher at the Maimonides Center for Advanced Studies, where she carries out a project on Maimon's critical skepticism. Her publications include an article in Revue de Métaphysique et de Morale titled Notes sur Maimon et sa critique du principe de causalité chez Kant, published in 2021. But what I'd like to mention in particular, that she's one of the editors of the Gesamtausgabe of Maimon's works, of which the first volume was published very recently. So Caterina, please, and the others, please show the volume. So this is really a great achievement. And so congratulations on this milestone in Maimon studies. And,
thank you.
And good luck with the production of the many volumes to come. Yes, and I should mention that this first volume was co-edited by Caterina and Yves Radizani. Okay, so as I already mentioned, the title of Idit's talk is Ampliative Analysis in Maimon's Thought, and I'm happy to give you the floor.
Thank you very much. I want to start with saying that it's a big privilege, especially these days, to be invited by Karim, Luis, and Pier Paolo to have this talk here. And before I start the official talk, I thought, Karim told me maybe not all the people, or most probably most of the people are not Maimon scholars. So I thought of 3 points I would like people to think about while I give the talk, which are the most important ones, because there's a lot of details that you don't need to remember and you don't need to understand, especially the mathematical. I have a few mathematical examples. It's mostly just to give an idea of what it means when Maimon talks about analysis in mathematics. So the 3 points are that analysis can be appliative, which means it's informative, it produces new knowledge, that there are multiple forms of analysis, not just the one that we usually know. I'll refer to it soon. And that analysis can be grounded also on intuition and not only on the principle of contradiction, which is also, for me, it was mind-blowing when I first saw this point at Maimon's work, because it was not obvious at all. So I'll share my screen. I have a PowerPoint. Okay, I'm sorry, I'm just, yeah. So Salomon Maimon is one of the less known yet well-appreciated members of the Enlightenment movement in Berlin at the end of the 18th century. Born in 1753, Maimon published numerous articles and books between 1790 until his death in 1800. I begin my talk with a short introduction of his philosophical work on analysis and invention, and then turn to a closer examination of his mathematical methods of invention. These methods are designed to be applied on Euclidean geometry, and they were influenced by practices of Greek geometrical analysis. I wish to show how these practices have not only shaped Maimon's mathematical methods, but also had an impact on Maimon's conception of analysis. I present Maimon's notions of analysis defined in a broader sense, which are ampliative, that is, informative, and not merely explicative. I then discuss how Maimon rephrased Kant's question concerning the possibility of synthetic judgments to include ampliative analytic judgments. I end my talk by arguing that analytic propositions in the broader sense are ampliative and not merely explicative because they serve as grounds for new propositions and have consequences. Sorry, I'm trying to, apologies, I'm good. In 1795, Maimon published 2 articles describing the outlines for his theory of invention. The Genius and the Methodical Inventor, and the other titled on the Use of Philosophy for Expanding Knowledge. In addition, a draft for an essay titled Methods of Invention was published posthumously. His theory of invention aims at finding new certain propositions and their connections to other known propositions. This theory is meant to enable the expansion of knowledge in a methodical manner, and not by means that are opaque to reason, such as luck or chance. In his articles on invention, he declares that the art of invention is entirely based on analysis. At the core of this theory lie 7 methods of invention, which he names analysis. Alongside these methods, there are also 3 methods of synthesis. For Maimon, invention in general is the art of finding arguments, or even more generally, it is the introduction of something new, including objects presented in experience, such as the telescope. In the narrow sense, to invent is to present a new object a priori, whereas to discover is to ascribe a new attribute to a given object a priori. In the broader sense, to invent is to form syllogisms, either by using analytic or synthetic methods. Invention is also defined by Maimon as different kinds of logical analysis and synthesis. When Maimon speaks of analysis, he usually means analysis in the narrow sense, defined as deducing a predicate from the concept of the subject. Alongside this concept of analysis, I present a definition of analysis in a broader sense that has yet to be discussed. I find that understanding the concept of analysis as it appears in relation to mathematics, based on practices of analysis that were used by Greek mathematicians, helps us to better understand the definition of the concept of analysis in a broader sense. Alongside the general definition of analysis as manifold in unity, Maimon presents various other notions of analysis. Analysis, in the narrow sense, is defined as deducing a predicate from the concept of the subject. It is grounded on the principle of contradiction alone. Analysis, in the broader sense, has 2 meanings and applications, one mathematical and the other philosophical. In both, analysis is not grounded on the principle of contradiction alone. In mathematical practice, this notion can be derived from the first 6 methods of invention referred by Maimon as methods of analysis, the 7th method being logical analysis. These methods resemble diarism, which is a method of analysis used by Greek geometers. In philosophy, analysis in the broader sense, which I name ampliative analysis, means deducing a predicate not from the concept of the subject, but rather from the object. This kind of analysis is grounded also on intuition, not only on the principle of contradiction. Maimon presents 2 kinds of logical analysis. The first is defined as forming syllogisms and is grounded on logical principles. For instance, syllogism Barbara, all MRC, all BRM, all BRC. Maimon mentions Lambert Orgadon as a work consisting of many examples of such logical analysis. Identity propositions, such as A is A, do not expand our knowledge, whereas syllogism, such as A is B and B is C, and therefore A is C, do produce new knowledge, A is C. The second kind of logical analysis is also called mathematical analysis and is grounded on both intuition and the principle of contradiction. According to Maimon, logic is missing a theory of invention. Logic may not be sufficient for a theory of invention, but it does play a very important role. Maimon's 6 kinds of analysis are brought forth to accompany and facilitate the use of logical analysis, not in order to replace it. His methods, let us first take a closer look into Maimon's methods of invention. The majority of these are methods of analysis, and there are 3 methods of synthesis as well. Although Maimon does not explicitly state that his methods of analysis were influenced by problem-solving techniques used by Greek mathematicians, it is clearly the case. It seems that Maimon was especially influenced, either directly or indirectly, by Proclus' commentary on the first book of Euclid's Elements. We find great similarity between the 2 works, not only in the methods, but also in the examples they use. Maimon studied mathematics for 2 years in a gymnasium in Altona, beginning in the year 1783, and presumably it was there that he first read Proclus' commentary. It is also possible that he came to know Proclus' work through Clavius' commentary to Euclid's Elements, a commentary cited by Maimon in his articles on invention. Another possible source of influence on Maimon's methods of analysis are the practices of theorism. In theorism, a mathematician specifies the limits of a solution, divides the possible cases of the solution, and searches for all possible solutions. I adopt Saito and Sidoli's distinction between theorism in a broad sense as the analysis of conditions, arrangements, and solutions of geometric problems. In the narrow sense, theorism is a part of the proposition presenting what is sought in the particular instance. As mentioned by Bernard, Pappus refers to theorism in relation to how and in how many ways a problem is possible. A similar idea is stated by Sidoli and Ishaya, who describe theorism as a heuristic analytical tool to find the conditions in which a problem is solvable or not, whether there is more than one solution, and the limits of the conditions of solvability. Whether Maimon knew what theorism is or not, we find in his work similar methods, such as analysis of the conditions of the possibility of a solution, analysis of the cases of a problem or a proposition, analysis of the cases of the solution, and analysis of the various ways according to which a problem can be solved or a proposition can be proven. Maimon's methods of invention are designed to be used by both mathematicians and philosophers. Although his articles on invention were published in philosophical journals, he addresses his work to mathematicians as well, suggesting that professional mathematicians could join him in developing his work further. Quote, "I would be very pleased if professional mathematicians who do not practice their science mechanically, but reflect on it, awakened by these suggestions, would join me in the realization of such an important plan, since I am only an amateur in this science," end quote. He aimed to advance not only philosophical, but also mathematical knowledge, is explicitly expressed, naming the type of mathematicians who would take interest in his work as philosophical mathematicians. Quote, "I wish that the philosophical mathematicians acknowledge the extent and importance of such an enterprise and would like to join me in its execution," end quote. Let us take a closer look into a few examples of Maimon's kinds of analysis presented as methods of invention. Maimon's first kind of analysis, called analysis of the conditions of a problem or a proposition, is divided into 3 types of conditions. First, examining the conditions to identify true and pseudo conditions. Second, identifying conditions of possibility of the solution. And third, identifying the conditions of the problem. The latter changes according to the point of view from which we examine the problem, whether we are the ones presenting the problem or attempting to solve it. The following example is meant to illustrate only the first type of condition. A true condition is a necessary condition. A pseudo condition is mistakenly considered as a condition, but as a matter of fact, the problem can be solved without taking this condition under consideration. Maimon presents the first proposition in Euclid's Elements, Book 1, on a given finite straight line to construct an equilateral triangle. So we're given the line AB, and then we construct 2 circles with A being the center of the first circle, B being the center of the second circle. And then we draw radii, and this is how we construct an equilateral triangle. This problem contains both kinds of conditions. Triangle and equilateral are true conditions of the problem. That is, they are necessary conditions. However, the given straight line AB, this is Maimon's idea, can be chosen arbitrarily, and therefore its size and position are pseudo conditions. But size and position, it's my addition. It has to do with Euclid's data. If someone wants more explanation, I can do it in the question time. Indeed, we require a determined straight line to solve the problem, but it can be determined arbitrarily. So we are required to have a line AB, but the determination of AB is a pseudo condition. The fifth kind of analysis, and here I count them as they appear in Maimon's work, so it's not chronologically here. The fifth kind of analysis is analysis of the cases of the solution. According to Maimon, sometimes we can arrive at a solution in more than one way. A solution is complete only when we present all the possible constructions of a solution to a problem. For instance, Maimon mentions the first proposition of Book 1 of Elements, which we just saw. In Euclid's solution, we construct a triangle above the given line. However, Maimon suggests that we can construct an equilateral triangle under the given line as well. Although not mentioned by Maimon, we can identify that in presenting an additional solution, the conditions of the problem and of the solution remain the same, and only the construction changes. Let's see it again. I'll show it again. This is in opposition to Maimon's third kind of analysis, called analysis of the cases of a problem or a proposition, where in each new case of a problem, there is a change in one of the conditions of the problem. I will not go into details here about the difference between the methods, and I continue to the next mathematical example. If someone is interested, I can answer about it later, or it appears also in the book that Karin mentioned. The fourth kind of analysis is analysis of the object. According to Maimon, there are many cases in which the given proposition or problem refer to one object, whereas the proof or solution refer to another object. In order to solve the problem, we are required to transform the given object so that we can apply on it propositions that will lead us to the sought solution. As an example, Maimon presents the fifth proposition of Book 1 of Elements. In isosceles triangles, the angles at the base are equal to one another. In Euclid's versions, the proposition has an additional part. And if the equal straight lines be produced further, the angles under the base will be equal to one another. However, Maimon does not mention it in his example, probably because he's following Proclus in this. Proclus in his commentary mentioned that the second part of this proposition is never used in the entire 13 books of Euclid's Elements, and therefore he does not refer to it in his own commentary. Maimon asks, how can it be shown that the angles at the base of triangle ABC are equal to each other based on previously proven propositions? This question leads to elements 1,4, where equality of angles is found. However, elements 1,4 refers to equal angles that are in two different triangles, whereas in the proposition we are trying to prove, the angles are in the same triangle. Therefore, in order to be able to use element 1,4 proving two triangles are congruent, we need to transform the object given in elements 1,5 so that the two objects of the two propositions can be connected. And this is the analysis of the objects. And pay attention, the analysis is actually a construction. I'm not showing you the details how element 1,4 is applied to prove elements 1,5. What is important here for our discussion in analysis today is that analysis of the object means in this case the following. First, we produce the sides of the triangle further, determine new points, and construct more lines. Only after this construction can we use elements 1,4 regarding congruent triangles where the respective sides and angles are equal. So we show this equality of sides, and we also show equality of angles. We return to element 1,5 by showing the congruence of triangles AFC and AGB. We can show that angle ACF is equal to angle ABG. And by showing the congruence of triangles BFC and CGB, we can show that angles CBF equals angle BCG. Using this equality of angles, we can show that angle ABC equals angle ACB, and that the angles under the base are equal to each other. The seventh, and now move to another kind of analysis. The seventh kind of analysis is what Maimon refers to as logical analysis, which he considers as a necessary condition in any proof or solution. Maimon does not present an example or specifies how this method is applied on specific geometrical problems and propositions. In Maimon's work on invention and logic, we find two methods mentioned by him as logical analysis. The first is regressive analysis. where we arrive from proposition A to proposition E through propositions B, C, and D, then the opposite direction is of analysis, and then it can be conducted from E to A. So from A to E is synthesis, and from E to A, that's the analysis. It's one of the two most famous types of analysis usually known in philosophy, the regressive one. The second method of logical analysis is the use of syllogisms, such as syllogism Barbara, which I showed earlier, together with what he calls the principle of determinability, wherein the predicate or determinant cannot be thought without the subject or determinable. In order to test Maimon's claim that logical analysis is a necessary method in any proof or solution, I attempted to apply both methods on logical analysis on proposition 1 of Euclid's book Data. Since the proofs are long, I do not present them here, and only mention that I show that both methods cannot be applied on this example, and not because I couldn't do it, but because there's an inherent problem. Let's say you try to construct it as a syllogism, and then you see that you have to use a definition that you can't put in the syllogism. So it's I don't just show that I can't do it, I show that it can't be done. Therefore, Maimon's claim that logical analysis is a necessary method in any proof or solution is not true. Only the principle of contradiction is a necessary condition of any proof or solution. Maimon also presents three methods of synthesis. The first is conversion, which helps us find new converse propositions, as well as discover whether a proposition is derived or original. If a proposition can be converted, it can be either original or derived, but if it cannot be converted, then it is surely a derived proposition. This leads us to the second method of a synthesis, which is generalization. When a derived proposition is given, we should search for a more general proposition. The last method suggests to assume a problematic proposition as true. At times, Maimon refers to it also as a method of analysis. He presents it as a method that can transform a problematic synthetic proposition into a necessary analytic one. The method aims to show how, by using demonstration, we arrive from a problematic proposition to an identity of a thing with itself. Unfortunately, his suggestion to perform this transformation proves itself lacking and unsuccessful. I skip here also the details. Very short, I can say that while he claims that we can arrive at a complete identity, which is A, what we do in Euclidean geometry is usually we find equality. You don't find identity in elements. And when Maimon talks here about the transformation of problematic proposition, it has to do with mathematics. So that's just one of the problems of his method. Applying examples from the elements emphasizes the fact that analysis is more than enveloping a predicate contained in a concept, and that the analytic method can be defined as more than arriving from a conclusion to its premises. This means that although the decompositional and regressive types of analysis are the central means to think about analysis, they're more certainly not the only ones. The effect that Greek geometrical analysis had on Maimon went beyond his notions of analysis in mathematics. I believe that it made him broaden the definition of analysis in his work on logic as well. Only once we turn to Maimon's notions of analysis arising from his work on invention, based on practices of analysis used by Greek mathematicians, can we comprehend his choice of calling something that is grounded also in intuition by the name analysis. Let us now turn to examine ampliative analysis as described in Maimon's logic. There are three different kinds of analysis of the object, all of which involve the presentation of the object in intuition. The first is analysis of the object as deducing a predicate immediately from the object, as an action of the understanding producing judgment. For instance, a triangle has three angles. The second is deducing a new predicate indirectly by using demonstration, in which case reason produces inferences, as in the Pythagorean theorem. The third kind is the fourth method of invention, which transforms a given object using construction, the method we just saw with the triangle, two different propositions with one with one triangle and the other one with two. Common to all of Maimon's notions of analysis in the broader sense is that they are not based on the principle of contradiction alone, but rather on intuition as well. Maimon's idea of analysis in the broader sense appears already in his book Essay on New Logic, published in 1794, which is a year before his articles on invention. There he points his arrow of criticism at Kant's concept of analysis and presents a broader definition of analysis. quote, analytic knowledge is knowledge that is deduced, entwickelt, and I'll return to the verb, from a concept of an object or from the object itself. Thus, it assumes the concept of the object. Here, Maimon says, or from the object concept of an object. Usually in the logic, he uses the phrase concept of the subject and object of the subject. In Maimon's opinion, Kant's notion of analytic knowledge is that which is deduced only from the concept of the object is too narrow. Kant defines analytic and synthetic judgments in terms of whether the predicate is contained, ist enthalten, in the concept or not. If the predicate B is contained in the concept A, then the judgment is analytic. If the predicate B is not contained in the concept A, then the judgment is synthetic. He refers to all judgments that cannot be thought using identity as synthetic, whereas according to Maimon, thinking identity is not considered as thinking. For Kant, an analytic judgment is only explicative in that it does not add any predicate that was not already included in the concept of the subject. While synthetic judgments, a synthetic judgment is ampliative in that it adds a predicate to the concept of the subject. What Maimon proposes in his broader notion of analysis is an ampliative notion of analysis. The difference, ampliative again, it's informative, it produces new knowledge. This difference in their approach is found already in the choice of verb to describe the relation between subject and predicate. Maimon uses the verb entwickeln, to educe. It's my translation to educe. I have a small passage in my book. I thought a lot about the different options, and that's the best English verb I had for it. So Maimon used to educe to describe Kant's notion of analytical knowledge, even though Kant tended to use the verb enthalten, to contain. Using the same verb as Kant would be problematic out of the context of a predicate contained in the concept of the subject. Therefore, Maimon uses the verb entwickeln to describe both his and Kant's notions of analysis. On the basis of Maimon's work on analysis of the object in his book on logic, I identify two ways to educe new predicates. This is in addition to Maimon's method of analysis of the object mentioned in the two articles from 1795. Maimon himself does not give any account to these three kinds of analysis of the object. He just uses this term, analysis of the object, in different places. First, we should distinguish between analysis of the object based on deducing the property immediately from the object, as in the example, a triangle has three angles, and between analysis of the object based on using demonstration to arrive at a new predicate, as in the example of the Pythagorean theorem. The method of analysis of the object is based on transforming the given object into the sought object. The first kind of analysis of the object that can be constructed from Maimon's work is that of deducing a predicate immediately from the object. This notion appears in his discussion of identities and analytic and synthetic thought in logic. According to Maimon, the thought of identities in which the predicate is deduced from the concept of the subject, often considered by philosophers as analytic thought, is in fact no thought at all, because the predicate is already thought in the concept of the subject. There is no action of thinking a new thought. I give here an example, just so you have already an idea what it means. I return to this example later. The definition of a triangle is a space enclosed by three sides. So to say that a triangle has three sides is, for Maimon, is not thinking at all, because you already thought three sides by thinking the definition, the concept before thinking of the new, so-called new, but actually not, completely not new, but found contained predicate three sides. This accords with Maimon's definition of thinking as an active action of the understanding, which thinks an object by thinking the rule by which it arises. Maimon calls analytic thinking the case where the predicate is deduced from the subject itself by thought, whereas in synthetic thinking, the predicate cannot be brought out by educement of the subject. He offers the following examples to illustrate the difference between analysis in the broader sense and synthesis. This, a quote, this proposition, for instance, a triangle spaced enclosed by three lines has three angles. Although three angles is not contained in the concept of the triangle, is nevertheless analytic, because the three angles appears out of its educement, what is contained in the triangle itself. But this proposition, a triangle can be right-angled, is synthetic, because being right-angled cannot arise from the already accomplished construction of the triangle in general. but rather it arises from the new construction of the right-angled triangle. And I'll add here, it's because we can have acute angled triangle. It doesn't have to be necessarily a right-angled triangle. Unlike any triangle, the triangle in general, where we always have three angles. Given a triangle, we can arrive at the new unknown proposition: a triangle has three angles, by turning directly to the object and not to the concept of the object, triangle, and by deducing from it the new property, three angles. Though Maimon specifically names such a process analysis, it does not explain how this analysis is in fact conducted and what justifies such a title. The change in Maimon's approach to naming the arrival at a new property, three angles, as analysis or synthesis occurred around the time of the publication of his logic. This is because in Essay on Transcendental Philosophy, published in 1790, he refers to the example as a proposition which is not a logical truth, but a synthetic truth, to which we can assign only subjective necessity, since we do not have the ground for claiming its objective necessity. In Gewata Mores, published in 1791, he states that three angles is a property of the triangle which is necessarily derived from the subject. It is not a determinant of the subject, that it is not a part of the definition of the triangle. Property is inferred from the subject, but is not part of its definition. Determinant is part of the essence. Therefore, three angles is not a determinant of the triangle, but a property, whereas three lines is a determinant of triangle and not a property. In his translation of Aristotle's Categories, published in the same year of logic, 1794, Maimon presents this proposition as an example of a synthetic judgment. Similar to his statement in logic, he claims that the predicate is not contained in the concept of the subject, but in the subject itself. The difference is in assigning the proposition once as synthetic and once as analytic, while the two texts were published roughly at the same time. This change in Maimon's assignment of this example to analysis or synthesis does not mark a change in the description of the example, but rather a change in this concept of analysis. This change has been neglected by previous commentators who have either tried to prove that the property three angles can be analytically derived as a conclusion from premises that are grounded in intuition, such as Freudenthal in 2006. They either refer to analysis of the object as synthesis, as Atlas did in 1964, or neglected this broader notion of analysis as analysis of the object altogether, such as Bregman in 1967. Much of the confusion involving in referring to the three angles as being adduced from the object itself is due to the question of the necessity of the connection between the subject and predicate. On the one hand, as mentioned by Freudenthal, Maimon sets out against assigning objective necessity to a connection that is not clear to the understanding, as it is not based on the principle of contradiction alone. On the other hand, when in logic Maimon discusses the grounds for different kinds of judgments, he assigns necessity to the connection of subject and predicate in analytic judgments of the kind of the analysis of the object, together with the example of the three angles. According to Maimon, the ground for identity judgment is in the concept of the object. He mentions the proposition, a regular decaedron is regular, as an example. Since the predicate is thought in the concept of the subject, its ground is in the concept. When the connection between the subject and predicate is in the object and not in the concept of the subject, and this connection is necessary, then the ground is in the object. Maimon suggests the proposition, a three-lateral figure has three angles. A lateral here means three-sided. As an example, its ground is not in the concept of the subject, since the predicate three angles is not contained in the concept of three-lateral figure, but only in its construction. When the connection between the subject and predicate is only possible, the object is a consequence of this connection. In this case, Maimon mentions the proposition, a triangle can be right-angled. As an example, its ground is not in the concept of the object or the object, but this connection itself is the ground of a new object, a right-angled triangle. And the same way, if we take an acute angle, we create a new object, which is an acute-angled triangle. We can only assume that Maimon intended to assign subjective and not objective necessity to analytic judgments of the kind of an analysis of the object. It seems that the broader notion of analysis as analysis of the object is meant to provide an analysis that is both productive and certain. As such, it can be helpful in the theory of invention. The problem that arises with this kind of analysis of the object, based on inducement of a new property by turning directly to the object, is that the ground for connecting predicate and subject is left opaque to reason. It does not offer any method to arrive at new knowledge other than looking at the object and searching the sought predicate by using the faculty of imagination. Maimon does not offer an explanation for naming the process of extracting a new property out of an object as analysis. Nevertheless, justifications may be found elsewhere in his work. We can identify two kinds of explanation. The first is based on the type of determination, and it explains the immediate inducement of a predicate. The second is based on conclusions of hypothetical judgments, and it explains the indirect inducement of a predicate. When in a determination, B is a possible determinant of A, a new object arises. Maimon's example is the judgment, a triangle can be right-angled. Being right-angled is a possible determination of a triangle, and a new object, which is a right-angled triangle, arises. When B is a necessary determinant of A, a new object does not arise, but A and B are connected in the object. Maimon's example is the judgment, a triangle has 3 angles. If B is contained in the concept AB, and not only in the object, then this connection between A and its determinant B is a priori objective, since what is considered as necessary for the concept is necessarily in regards to the object as well. As a result, analysis of the object can be defined as finding that B is a necessary determinant of the subject A, when their connection is in the object. If their necessary connection is in the concept, then it is the analysis of the concept. Both processes are named analysis since they dissolve as necessary not. This is in contrary to synthesis, where the connection between determinant B and determinant A is not necessarily, but only possible. In this case, the process is called synthesis since we compose the determinant with the given determinable. However, what is lacking is an explanation of how we arrive at the knowledge that the determination of an object that is not a part of its concept is necessary. Not a part means a determination, of course. In the second kind of analysis of the object, the inducement of a new property from the object is not immediate, but indirect, using demonstration. This difference between the two kinds of analysis of the object does not reside in Maimon's description of analysis of the object, but is implicit in the examples he uses. Maimon refers to the Pythagorean theorem, which is element 147, as analytic knowledge. And here it is a long quote. Therefore, I expand the explanation of analytic knowledge further, as I understand it, as produced knowledge by inducement in general, of the concept or the object, so that according to my assertion, therefore, not only the attribution of already thought essential determinations to the concept of the object belongs to the analytic knowledge, but even the attribution of the properties of this essence. For instance, the concept of a triangle arises owing to the synthetic judgment. Space can be enclosed by 3 lines. However, the proposition in which properties are attributed to an object belong to analytic knowledge, although they are not deduced from the concept, but rather from the object, such as, for instance, the Pythagorean proposition. Maimon renames knowledge that is in Kantian terms synthetic, finding new properties of an object not based on the principle of contradiction alone, but also based on the construction of an object in intuition, as analytic. To the realm of synthesis, he leaves only the creation of new objects. Thus, a triangle is created as a new object by synthesis, and by analysis of the object, we find that it has 3 angles. By adding the determination right-angled as a dependent predicate to the subject triangle, we create the new real synthesis right-angled triangle. It has a new consequence, the Pythagorean theorem. By referring to an action that involves not only thought, which is based on the principle of contradiction alone, but also cognition based on the principle of contradiction as well as on the intuition, Maimon presents a notion of analysis that includes not only analytical thought, but also analytic cognition. It is not merely explicative, but rather ampliative. Although not mentioned by Maimon, this kind of analysis of the object differs from the first in that the connection between the subject and predicate is indirect. We need to use inference to arrive at the sought knowledge. The relation of determinability here is not immediate, but indirect. To better understand the difference between the two suggested kinds of analysis of the object, we can turn to Maimon's explanation of 2 kinds of conclusions. Conclusions are determined by Maimon as a relation of the given manifold to the unity of consciousness that is not immediate, but indirect, and not intuitive, but symbolic. Maimon writes that the relation between the subject and predicate in the conclusion is not immediately known from the relation of determinability. We must first turn to the knowledge that arises immediately from the relation of determinability of the subject and another predicate, such as A is B. Subsequently, we turn to consider the predicate as a subject and its immediate relation to another predicate, B, C. And finally, we attribute the first subject with the predicate which is not connected with it, in a direct relation of determinability, A, C. In addition, he mentions that immediate conclusions are judgments where the connection between subject and predicate is immediately recognized, so they are indemonstrable. Hypothetical principles are immediate conclusions, and hypothetical judgments are indirect conclusions. Connecting subjects and predicates immediately is judging and is in action of the faculty of understanding. Connecting subjects and predicate in an indirect manner is inferring, and this is an action of the faculty of reason. Therefore, the two kinds of analysis are conducted by different faculties. The first is an act of understanding, whereas the second is an act of faculty of reason. As for synthesis, synthesis in general is unity in manifold. In the narrow sense, it is defined as the introduction of a new object a priori. In the broader sense, it is not defined, but implicitly includes a range of cases. In relation to Maimon's work on invention, synthesis is defined as a process where we begin from something given. The given can be a determinable, an object given in intuition, or a proposition wherein the ground of the connection between the subject and predicate is not in the concept. This broader notion of synthesis also includes the introduction of a new predicate, what Maimon at times calls analysis of the object. The introduction of new definitions of synthesis in the narrow sense and analysis in the broader sense led Maimon to present a new version of Kant's question concerning the possibility of synthetic a priori judgments. The question, as Maimon refers to it, is how are synthetic or analytic judgments whose predicate is not thought as contained in the concept of the subject, but rather in the subject itself, possible? This question centers around the possibility of knowledge that is not absolutely a priori and not pure. In Maimon's term, pure is only a product of the understanding. He also has a very strict definition of a priori. I can answer about it in the questions if someone wants. Maimon divides Kant's synthetic a priori knowledge into two types of knowledge, synthetic and ampliative analytic. In synthetic judgments, such as a triangle can be right-angled, a new object arises, and the relation of determinant to the determinable is only possible and known not to be necessary. This kind of judgment cannot be transformed into apodictic judgments, wherein the predicate is necessarily contained in the subject, without a change of quantifier. That is some and not all. That is, synthetic judgments in the narrow sense cannot be shown to be analytic in the narrow sense. In ampliative analytic judgments, such as a triangle has three angles, a new property is found where the connection between subject and predicate is found in the object, and the relation of the determinant to the determinable is necessary. At times, Maimon considers this kind of judgments as apodictic and others as esoteric, but in either case, it is not problematic. Therefore, it is not impossible to show that the predicate is contained in the concept of the subject and not only connected to its object. Hence, the application of Maimon's definitions of synthesis in the narrow sense and analysis in the broader sense leads to the conclusion that the first, the synthesis, cannot be shown to be analytic in the narrow sense, whereas the latter, which is the analytic in the broader sense, can be shown to be analytic in the narrow sense. Comparison of Maimon's definitions of the two pairs of concepts, analysis and discovery, both defined as introducing a new attribute, and synthesis and invention, both defined as introducing a new object, raises the question whether the difference between discovery and invention is indeed only subjective as Maimon asserts, and therefore also the question whether the difference between analysis and synthesis is subjective. Were the difference real, Maimon should have presented for each a separate theory and method, theory of invention and a theory of discovery. He also should not have interchanged the two terms, as he often does. Supporting the claim that this difference is only subjective are his methods of invention, which are used for both invention and discovery. If we assume this difference to be subjective, it is inferred from the comparison of definitions that the difference between analysis in the broader sense and synthesis in the narrow sense is subjective as well. Since the difference between synthesis and analysis is based on different relations of determination, possible and not necessary in synthesis, and necessary or yet unknown in the analysis of the broader sense, then using these definitions, our finite understanding cannot overcome this difference. The solution I offer is to turn to the idea of infinite understanding as creating real objects by thinking their concepts, Maimon's idea, of course, thinking all possible determinations, together with an appeal to the notion that it is only in degree that our finite understanding differs from the infinite understanding. Being created in the image of God means that the finite understanding creates new concepts and objects and induces new attributes and properties from them. But unlike the infinite understanding, the finite understanding does so as different processes and in the form of intuition, as forms of intuition, space and time. Our finite understanding is either given the determinable and thus seeks for its determinant, or is given the determination and seeks for the determinant. What for the finite understanding is given and sought is for the infinite understanding only thought. I now turn to the last part of my talk. I argue that analytic propositions in the broader sense are ampliative and not merely explicative because they serve as grounds for new propositions and have consequences. Maimon's work on grounds as well as consequences is an extensive topic, and I won't be able to go into the details here. What is important to mention here today are the following points. Ampliative analytic propositions serve as grounds and have consequences, and as such are judgments in the narrow sense. Maimon distinguishes between judgments in the narrow sense, which provide the ground for other judgments and thus expand our knowledge, and judgments in the broader sense, which express the act of judging that is abstracted from the ground or the transcendental conditions and does not consider consequences. Ampliative analytic propositions are judgments in the narrow sense. Identity judgments, however, are not judgments in the narrow sense, since they do not expand our knowledge. They are judgments only in the broader sense. Consequences, this is the second point. Consequences are a necessary criterion for ampliative analytic reasoning, since it is what distinguishes it from identity propositions and what makes them informative. In Maimon's terms, one of the expressions of this idea is that the conclusion has to be different than any of the premises used in a syllogism. I suggest the following example. The proposition a triangle has 3 angles serves as a ground for proposition 40 in Euclid's data. If each of the angles of a triangle can be given in magnitude, then the triangle is given in form. Euclid's proposition is one of the consequences of the proposition a triangle has 3 angles, which can be used as a major premise in the demonstration and thus serve as a ground for data 40. Another proposition in which the proposition a triangle has 3 angles serves as a ground is elements 116. In any triangle, if one of the sides be produced, the exterior angle is greater than either of the interior and opposite angles. And I come to finish the talk. It is unknown what impact Maimon's thought on ampliative analysis had in the course of the history of philosophy. What is known is that in the same text where Bernard Bolzano presents a notion of analysis defined in a broader sense, in Theory of Science in 1837, he mentions Maimon's work on logic and the distinction between propositions which bear new consequences to those that are not informative. And he even mentions the number of page in logic. And he refers to Maimon several times in this book, but specifically in this in the same passages where he talks about analysis in the broader sense. This might indicate that Maimon's ideas had some bearings on Bolzano's work and thus fruitful to an extent. And by this, I think Maimon may have, again, it's unclear the extent of Maimon's influence on Bolzano. Bolzano is the father of theories of grounding and theories of consequences, and is one of the great uncles or forefathers of analytical philosophy today. But it might be possible that Maimon's wish to influence philosophical mathematicians or mathematical philosophers may have come true, because Bolzano is very known also for his mathematical work, not just philosophical work. Thank you very much.
Okay, thank you, Idit. That was very interesting and rich. And it's also very interesting that Maimon may have had an impact on Bolzano and hence on the development of analytic philosophy. So that's maybe something that you or someone else can pursue further.
I'm working on it currently.
You're working
Yeah,
on
that's my current. Yeah.
Okay, so maybe we should invite you next year again to hear the results. Okay, but first of all, let's turn to Katarina's response.
Thank you. Well, yeah, Maimon had an influence on many authors, so that would be not that strange. So first and foremost, I'd like to thank Karin and also the Leuven group for inviting me to participate in this event. I'm very glad and also found its presentation very insightful, engaging. So I'm eager to share some thoughts with her and also with all of you. So before delving into details, I'd like to start with a general observation, particularly for those who may not be well acquainted with Maimon's philosophy, although I can see there is our little group of Maimon's fans. So Idit's work on Maimon's theory of invention and also her observations on the concept of analysis are truly pioneering because there are no similar studies on it. And even the most comprehensive and classic works on Maimon's, like, I don't know, I think about Engstler work that is very famous, or Atlas works, they don't even mention this theory. So this is very new. But besides its originality, I'd say that the significance of her research lies in the attempt to reconstruct Maimon's notion of cognition, his relation to Kantian philosophy, and his contributions to the domains of mathematics and geometry that are all unknown paths in the studies. So the central thesis of the presentation, as I understand it, posits that Maimon's notion of analysis goes beyond mathematics and had an impact on his philosophical work. So two key ideas emerge from this thesis. The first one claims that Maimon's notion of analysis is ampliative, not only explicative, because it could be the ground for new propositions. That's the first idea. The second one shows how Maimon's notion of analysis is used to rephrase Kant's question concerning the possibility of synthetic judgments. So I will dwell on each idea and then add some suggestions and remarks. So let's start with the notion of ampliative analysis. So I believe that interpreting Maimon's analysis as ampliative offers valuable insights into his discussion in section 5, chapter 8 of the new essay, the essay on new logic, when he talks about the different kinds of knowledge. Moreover, Idit's connection of this concept to Greek mathematics has a huge historical significance because she's showing how Maimon, and to what extent also Maimon is contributing, is in the discussion about Euclid's geometry that was going on around 70-80. Started with the translation of Euclid's Elements by Schwab and Lorentz, and then put forward by people like Proclus that she was mentioning before. So it's also very important to see how much Maimon's production was huge and large, and how many debates was he involved into. But conversely, I find it challenging to trace the developmental trajectory of this notion in Maimon's writings before 94-95 and also after. So sometimes it appears that his general notion of analysis diverges towards an ampliative one. For example, in the Categorias des Aristoteles, he claims the opposite, like that analytical judgment does not ampliate our knowledge. And given that, as also Idit notes before, Maimon typically refers to analysis in a narrow sense as adducing a predicate from the concept of the subject. So given that, one might question the emphasis on ampliative analysis and its implications for our understanding of Maimon's logic. Going to the second idea about the rephrasing Kant's question. So I find Idit's attempt to connect Maimon's analysis and Kant's inquiry about the possibility of synthetic judgments very illuminating, because it helps elucidate the distinction between their concept of knowledge. So as she shows, Maimon consistently maintains that an identical judgment, or what Kant might call analytical, is not even thinking, since it merely repeats, let's say, what is already contained erhalten in the concept of the subject in a judgment. In contrast, Maimon introduces another type of judgment, which could provide cognition, but without being a synthesis. So without bringing together different elements or manifolds into a unity, which is the definition of synthesis. So instead, this judgment develops what is inherent in the object of the judgment, albeit not apparent, let's say, from its concept. And moreover, I think in this way, Maimon has tried to solve some maybe lack of clarity in Kant's text, because it seems that when Kant refers to analytic judgment, nothing, where nothing new is said, he's not thinking about a tautology. He's not thinking about A is A, but just about a concept that we already know. Like, for example, in his examples in the prolegomena, like yellow gold is a yellow metal, for example. It's not like saying A is A. However, I have the impression that Maimon is not as far from Kant as it could appear, because, for example, as he claims in the new essay, in the essay, A New Logic, right after explaining his notion of ampliative analysis, he says, I'm quoting, nevertheless, this deviation from Kant concerns merely the definition of words, as we are fully agreed regarding the thing itself. So it seems that Maimon is examining various forms of knowledge and changing Kant's terms, rather than actually rephrasing Kant's question about the possibility of synthetic judgments. So as I understand it, he's altering the definition of an analytic judgment. From my perspective, it seems that Maimon's notion of ampliative analysis may not significantly influence his philosophy beyond the realm of mathematics. It's mentioned in the essay, primarily serves Maimon's specific purpose within that section of the book, when he categorizes different kinds of knowledge. So, for example, he suggested that synthetic judgments are only possible in mathematical objects, while ampliative analysis pertains mainly to theorems, like the Pythagorean one, as we saw in one of the quotes of Idit. And another little clue could be found in his article on the expansion of knowledge, where he formulates his theory of invention. And there, while distinguishing his approach from that of Leibniz and others, who sought a comprehensive theory of inventions that could sprout through all the human knowledge, he claims, I just want to limit myself to mathematics and physics. So regarding the relationship between Maimon's notion of analysis and Kant's question about the possibility of synthetic judgments, I believe that it could be important to define what kind of understanding of Kant's inquiry do we have in mind. So one, which is a more in a more neo-Kantian style, is to see Kant's project as seeking the conditions of possibility of science, physics and mathematics, as he says, for example, in the prolegomena. But in this case, it would be interesting to see what kind of role could Maimon's ampliative analysis play in the knowledge we have of physics and mathematics. But maybe things change if we understand that Kant's authentic project consists of raising the question about the possibility of metaphysics as a science. So how it is possible to make synthetic judgments which expand knowledge, but to do it a priori, so without the support of the experience. In this scenario, the inquiry about the conditions of possibility of nature or physical mathematical knowledge would just be a part of a project aimed to trace the limits of metaphysical knowledge. So in this case, I think that Maimon's notion of ampliative analysis could be far from it. And finally, I found intriguing Maimon's distinction about the concept of the object and the object itself in the judgment. So I just want to suggest, but this is really just a suggestion, to try to understand it a little bit more. I don't know if Maimon is drawing inspiration from Aristotle here. In many occasions, for example, in the first book of physics, in the De Anima, in prior analytics, almost everywhere, Aristotle distinguishes between what is cognizable and clear to us and what is cognizable and clear in its own nature. So, of course, he is not thinking about a difference between a thing in itself and an appearance, but he is establishing a methodological principle. So it means that research must begin according to what we know of the thing and then arrive at what the thing is. So perhaps Maimon understands that the object of an analytical judgment is identical in the thing, but not for us, because for us it would be an expanded or ampliated knowledge. So in other words, to make it clearer, the notion of an analytical judgment is ampliative for our knowledge, but not for the thing in its own nature, as a synthetic judgment would be, because it determines a new object. We all know that Maimon was very much into Aristotle's philosophy, and especially in those years when he translated Aristotle's categories. So I would like to raise 3 questions. The first one is related to what I say, so regarding the sort of thesis that Maimon's notion of analysis impacts his philosophy. I would like to better understand how much, what is the nature of this impact. The second is very personal, because you know that I love Maimon's skepticism, so I would like to to tell me, how would you see this notion of ampliative analysis into in the realm of Maimon's critical skepticism? And also, this is just out of curiosity, almost at the end of your talk, you were referring to the idea of an infinite understanding in order to answer the issue about the differentiation between synthesis and analysis. So I was wondering, how would you explain this idea within the context of Maimon's 1794 project of a new logic, where this concept is not developed anymore? Thank you.
Okay, thank you very much, Katrina. And so, Idit, you're free to respond briefly to Katrina's comments, if you want to.
Thank you. Thank you, Katarina. I'll answer first the 3 questions, and then if I have time, I'll say a few more stuff about some of the points you mentioned. Thank you so much, first of all, for spending the time to make the commentary, a well-made commentary. So about the impact.
That's my pleasure.
Question. Yeah, thank you. So about the impact is a wonderful question. Before I saw Bolzano, I thought there was really no impact at all. And again, Bolzano is a very small, I'm still working on how much the extent of it. In Maimon's own work, I also until now haven't seen it again in other works after 1795. And as I mentioned, like you said, I also mentioned that before, also it doesn't mention it. So you have only these texts that I mentioned. Again, I need to go through all Maimon's writings again, looking for when he uses this, which I have not done yet. But yeah, but the impact, I think, is not so big. And that's why, for me, it was a huge surprise to see it. I think at the first, I didn't even understand what's going on. I started working first on the theory of invention, and then I'm reading, and then I see these types of analysis, all the mathematical ones, and I'm thinking, analysis, this is synthesis. And I didn't mention it in the talk, but the book of elements is the book of synthesis. And the book of data is the book of analysis. And Maimon, just before he presents all these methods, he mentions Schwab's text from 1780, which you mentioned. And then he goes, and all his examples are on elements. And I'm thinking, wait, he has the book of analysis. He knows it. He quotes or refers to passage 3, from the thoughts of analysis that Schwab writes. But then all these examples are on synthesis. And for me, it was mind-blowing. And then I was very lucky that somehow I was reading the logic and at the same time visiting some historians of mathematics. And when we were working on mathematical analysis in Greek mathematical geometry, and when I told them, what is this? But the book of elements is synthesis and all that. And they were like, no, this makes a lot of sense. This is analysis. They look at Maimon and say, yeah, this is analysis. It makes sense. So the impact beyond this, I don't know. And like I mentioned, and you've mentioned, for sure, if nobody knows anything about Maimon, then I would say analysis is when a predicate is contained in the concept. I would not go to explain about the ampliative analysis, because most Maimon scholars would not think about it. So but what I did want to say about it, I'm sorry, I'm putting my comments in between the answering your questions. So Schwab, check. My second thing was when you say about Maimon that he says, "Oh, I'm supporting Kant's claims. I'm just changing the words." He does it also in the essay on transcendental philosophy, just after he says that synthetic a priori judgments can be turned into analytic ones, which Kant will not agree. So he does it often, and I think it's something he says to make the reader feel more easily to convince them that he's not talking nonsense. But I don't think if you read the content, then it's completely...
Fair enough. You're right. You're right. I can't object against this.
And also, I think for me, with Maimon is, when I read, it always has to be in a context, what he's working at the moment, because I can also find him, he's not 100% coherent throughout his work. Like I showed, for instance, with this example of a triangle has 3 angles. I mean, he could have used just other examples to make the similar points in different times, but he always uses the same example. So about the skepticism, your question was, how is it related to skepticism, or?
Yes, how do you see this notion of ampliative analysis within the limits of Maimon's skepticism?
So yeah, it's on both sides. On one hand, I'm now talking about the mathematical methods mostly, but I think it applies also for the logical one. What he does with, let's say again, the theory of invention, mathematical methods, he works on mathematics, like you mentioned, because he wants to start with what is, with inventions that already exist. That's why also he goes to Euclid. It doesn't begin a theory that when he talks about philosophy in relation to invention. He always talks about castle in the sands and stuff like that. He wants to start with something that's existing. Why? Because when people don't do that, such as he mentions there Leibniz, then you have the question, how is invention possible? And Maimon says, I want to avoid this question. I'm saying here are actual inventions. Nobody would argue with elements, for instance. And I want to see from them how I can extract methods of invention. And I think if you look at the logical concepts, you already have the object. So at least the possibility of when you create a new object, for instance, with a right angle triangle, let's say you never had a right angle triangle, and you say, okay, I have this triangle, I just managed to do an acute one, and I constructed it so nobody can contend that it doesn't exist, or it's not actual in space, because I just showed in a diagram. And and like the decahedron, which you know that you have a perfect concept, but you can't build it. And in Euclid's Elements, I think it was it's either the last or one before the last propositions, you see that there's only 5 perfect equal-sided figures. And what about all the rest? You have their concepts, but you can't construct them. And he shows, he proves that it can't be constructed. So here you start, so let's say with synthesis, then you can't, before showing that it is actual, you can't say that there is a right-angled triangle. That's why also Maimon, that I didn't refer to it at all, but in the logic, when he talks about synthesis, it talks about real synthesis, and it has 3 criterions, and one of them is showing, presenting an object in intuition. The third one is having a consequences, and the first one is to have an absolute object, wherein the subject can be thought without the predicate, but the predicate can't be thought without an object, which means you can think of a triangle without thinking right angled, but you can't think right angled without thinking, and here there's a bit of a problem, but angled. Anyway, all this to say that I think here also you start with something that is given. So you can ask question about the given, but you can't ask whether it's given, because this is already out of the table. And this connects me to what you said about Aristotle. When you were speaking, I thought, I start with what is, not what should be. And this is something he says in his commentary on Bacon. And I think that's also a part of his skepticism. He's trying, of course, at some points he might talk about symbolic recognition, like in an article. But in general, I would say he would try as much as possible to talk about actual objects, real objects. That's why he's very careful with metaphysical truths and the thing in itself. So I think here comes the skepticism. So what I forgot to say, what it said already in the beginning, his theory of invention is meant to find methods that we can apply to have more certain propositions. So the idea is that we use these methods so we can have not just new knowledge, but also we can increase the degree of certainty. I'm supposed to publish, like soon will be published an article also about this, about the skepticism and certainty in his theory of invention and exactly how each method is doing this. But regarding the skepticism, then I think the main point would be that something is given first. And the third point about the infinite understanding. So my example would be that the infinite understanding thinks triangle, and it can think triangle as right angled, acute angled, and I forgot now how to say the broader one in English. There's a mathematical term which I forgot how to say it. There's acute, an angle is under 90 degrees, right angle is 90 degrees, and obtuse angle is more than 90 degrees. So the infinite understanding thinks triangle with all the determinants together, and since it does not need forms of intuition, and it can think all concepts at the same time, then it's not a problem, and determinations. But for us, it's a problem, because if you have right angle, then necessarily you don't have obtuse angled. That's why also I mentioned with the esoteric problematic that you can show why, even if you don't know, if you can't show now in the concept why 3 angles comes directly from the concept or isn't contained in the concept of triangle, it's not impossible, but you can't never show right angled in the concept triangle, because you know you have things which are not right angled connected to it as well. So I think in this sense, I hope it helped. Yeah, okay.
Okay.
And
oh, sorry, but maybe if is it okay if we now go to the audience, and maybe in answering other questions you can squeeze in some other thoughts that came up. So the floor is open, and maybe you can use the hand icon. Daniel?
Yes, thanks a lot, Idit and Katharina, for the great talks. It's very, very interesting, very informative. I have a question referring to the last aspect you spoke about, the infinite understanding and its backgrounds concerning Maimon's epistemology. So, Katharina, you also mentioned Leibniz in this context. And I'm just wondering, because I'm very interested in this connection. So I have just been wondering, what do we think about a possible influence of Leibniz calculus, of his version of the calculus on Maimon's theory in this context?
You mean in the context of infinite understanding, or?
Yes, exactly.
Why? Because when I think of Maimon, and you mean like when I think of calculus, I think like differentials and integrals, and then I think of Maimon's attempt in the essay to say that he doesn't call it nomina, I don't remember how he calls it there, but from the concept, I think it was the concepts of understanding, you can somehow arrive to the objects in intuition. Again, I do a very big rephrasing. I don't remember the exact concept he's using there. I think it's chapter 6 or 7. But I don't remember the infinite understanding there. So I'm not sure I understand.
Yeah. So maybe that's a bit complicated because I rather refer to Maimon's first essay, the Versuch über die Transzendentalphilosophie from 1790, where Maimon calls his own position a Leibnizian position. And in this context, I think his own concept of an infinite understanding is strongly influenced by Leibniz monadology, and in this context also the theory of calculus. So yeah, I am just interested in what you think about Maimon's connection to Leibniz in this
okay.
works. Yeah.
So because I thought you meant the differential with the infinite, this I didn't understand, but I also referred to this book, like the first book he had. There's a chapter, I think it was Grosse, where he even has this triangle where you can see like his like diagram to show how it progresses. I think it's influenced by Leibniz by so many things, even in regards to invention, to the positive and negative. Like I said, with the possibility of invention. So, for instance, he learned from Leibniz's mistakes and tried to avoid that problem. Regarding the infinite understanding, it's an idea of reason for Maimon. He doesn't claim that it's like real or actual, and I believe that for Leibniz, I don't remember which like concepts or notions Leibniz would use it, but I think Leibniz sees it not just as an idea of reason that gives some kind of systematicity to his.
Yes. Yeah.
But so and Maimon uses it more as a tool than actually. So because I think like for Leibniz, the monads, they exist, like there are monads. And for Maimon, it's exactly what he would not want to do. He, in many places, everything that is not somehow given, he would really be careful. He would use it only as an idea of reason, or perhaps maybe as an idea of understanding, but something that we can't know anything about, so we would not. It would not give a positive, like an affirmative judgment about it. And I think for Leibniz, that is different. But I'm trying to remember now which methods. So for instance, Maimon has the generalization. Leibniz has universalization, which is different as a method of invention. For Leibniz, you have one solution and it solves automatically 34 cases of one problem. And what Maimon does, he doesn't do this because he's not that good a mathematician. But he says, okay, if I have all 34 cases, then I can go to the general one. So in this, I have Leibniz in mind. Yeah, and there's other places, of course, but I mean, Maimon is a Leibnizian. I'm just trying to get an article published about why Maimon is also a Baconian, which nobody ever talks about, and Maimon is a Spinozist, and Maimon is, well, is like Kantian, anti-Kantian, not, I don't know how you want to call it. It's not anti-Kantian, the not Kantian. I don't know which phrase to use, but it's so many things. It's Aristotelian, it's everything. And he has a commentary on the Theodicy, and more than half of it is about Maimonides. So I don't know. I mean, yeah. And then again, like if you look at Maimonides, you look at this commentary on Maimonides, and then you have so much science in it, and Euclid, and Aristotle, of course, and you have so many other stuff. So yeah.
Yeah, thanks a lot. That's sounds very, very interesting, and yeah, I'm very much looking forward to your article on Bacon. Yeah, thanks.
Okay, very well. Further questions, Luis?
Yeah, so thank you so much, Idit. This was fascinating, and I'm very happy to hear your talk. So I was wondering if you could say a little bit more about the status of mathematics for Maimon, because for Kant, mathematical cognitions are synthetic a priori, And you made this distinction between propositions that are analytical or ampliative analytical in mathematics, and some are syntactical. And what is mathematics as such? And if you could, maybe if you could also make a connection between this and the whole discussion in the end of the 19th century about the status of mathematics, whether it is synthetic or analytic, that was very important also for the emergence of analytical philosophy with Frege and so on.
Thank you. So I hope I remember all the parts, because it's one question, but it has a lot of. Wait, so at the beginning was, just now I remember the 19th century, the beginning was...
so the status of...
mathematics as such, now I remember. I think it's hard to say what is mathematics as such, except for its a priori. And Maimon, again, he has two notions of a priori. The absolute a priori is not, we have like regular a priori, like Kant, which is any cognition before a experience, but he also has absolutely a priori, which means that you think of the object together with the concept, and not before, which means like the cognition and the object is not prior to the cognition, which means there isn't like a, let's say in triangle, you have a triangle, and then you have a cognition of the triangle. But absolutely a priori is when you have a number like the number 2 when you think about it in the definition of the ratio between 2 and 1, like double. And then you have the cognition and the object at the same time. Like the number does not exist before. So first of all, when I say now a priori, I mean the regular a priori. So for him, he always says that, also like in his articles on invention, that he refers to mathematics because it's an a priori. And he also says, I don't refer to philosophy because it's too speculative. And I don't refer to physics, although like, as Katerina said, he does say a few words about discoveries in physics, and he has another, in 1793, he writes a commentary on Bacon, and he has 2 essays attached to it. And one of them is a short history of mathematical inventions. And then again, you open it and you see just like, not half of it, but almost half of it is astronomy. So, I mean, of course, astronomy belonged to mathematics at one point, but at his point, it was already physics. So in physics, what you have is that you need experience. So that's why also you would want to use mathematics. And I think also because I'm not sure what came before, but his notion of knowledge is a propositional, and the connections between knowledge is logical connections. And even though Euclid's Elements, people try to show it, or let's say write it down in a form of syllogisms, and not successfully. So in some way, it is not the best example that Maimon has. I think what Maimon had in mind is knowledge about objects that are given in intuition, that you can, as much as you can, try to express within as relations between propositions. And in physics, the more you go to experience, the less easy it gets. And regarding, so math as such, it's a difficult thing to say, because he wrote the textbook on algebra. Didn't write much about algebra itself, only here and there, like in logic and other places. So it depends again, like which algebra is much more abstracted than geometry. In geometry, you need to have an object that is given. In algebra, it's much more symbolic. So I think mathematics as such is a difficult thing to say, but if I would say anything, then it's a priori, and you don't need experience. And about the 19th century, so my current project is about ampliative analysis in Bolzano and Maimon, and I hope my next project, I'm still working on the details, will be a history of ampliative analysis, because you see a notion of analysis in the broader sense also in Frege, where he talks about his number, a definition of number, which is what I assume what you had in mind when you talked about analysis and synthesis. So again, I still haven't found a place where Frege says, "Ooh, and Bolzano in this page says this and this," but I'm interested to see the connection between all these, and also to see if there were other notions of ampliative analysis, because also, as far as I've seen, many stuff that I thought were original by Maimon, I read a bit more, and then, for instance, in his methods of invention, when I first read them, I thought, wow, that's amazing. He thought of constructing the triangle also under in Elements 101, which I showed, also under the line. That's amazing. And then I look, oh no, Proclus said it before. So let's see. But yeah, I hope I answered.
Yes, you did. Yeah, thank you so much.
So that sounds very exciting. So Timothy, is it okay if we first ask Farhad to ask his question?
Yes, absolutely. Yeah.
Thank you. I couldn't raise my hand. Thank you a lot. So I'm very perplexed. So I need another guide by Maimon to get me out of this perplexion. Okay, so as a philosopher who comes after Kant, I'm not convinced. Do you hear me well?
Yeah.
Okay. I'm not convinced why we should follow Maimon's non-systematic enumeration of all these kinds of analyses. It reminds me of the Occam razor. So we are producing unnecessarily new concepts, and we don't ask whether all these frame of thought can be explained within the Kantian framework. And the way the Kantian framework is addressed isn't, and it's criticized, is not convincing. It's not that much strong. So as you mentioned, the main issue of the a priori synthetic judgments or propositions in Kant, many people, and Boltzana, if we refer to Boltzana, every critique of Kant picks on the containment relation, the way Kant in introduction defines synthetic propositions in terms of something that is not contained in the subject. But to be fair, he, in the metaphysical deduction and elsewhere, also defines synthesis, a priori synthesis, in terms of the unity of the manifold, as you also mentioned. So it's the act of bringing together different representations. And we can exactly apply this kind of a prior synthesis that Kant talks about to the examples in geometry that you were talking about, the way you extend the lines, the way you want to try the demonstration. So I don't find why I should call this the ampliative analysis by an appeal to a demonstration to prove something which is, which Maimon would say is explicit, is hidden, rather than saying that, no, we are just referring to our a priori intuition of space and time, as Kant would say, and this is, again, a synthetic a priori judgment or act that we are undertaking. So, yeah, so what would you say to a Kantian counterattack to Maimon and say, okay, I was systematic. All you do is just introducing these concepts without even asking why I was up to my system and everything, and it adds to confusion rather than providing any solution. Given the fact that all the examples he's talking about can be explained within a Kantian framework, I suppose.
Okay, very well put, Farhad. So let's turn to Idit's answer.
Yeah, thank you.
Okay, so it has two answers within Maimon's philosophy and for a Kantian. So I'll start with the Kantian because I think it's more interesting for most people here. Of course, you can just say, okay, all these propositions are synthetic a priori, point, I move on. But what Maimon does, if you look at the synthetic in a narrow sense and the ampliative analysis, you have, I think, better understanding of the connection between them. Like it's what I try to explain with the determinant, if it's possible or necessary. Again, it's a problem to say it's necessary because it's opaque to reason, so you have to ask what kind of necessity it is. But I don't remember Kant referring to the question of the determination of the difference between synthetic in the sense that is creating a new object and analytic in the sense that you find a connection that is necessary. From what I remember from Kant, it's only about what Maimon calls as ampliative analysis, and he mentions as synthetic. And here I come somehow to Maimon's philosophy. Already in the first book, he tried to show, he failed, but he tried to show that some of the examples of Kant's synthetic a priori are actually analytic, by showing that the predicate is included, is contained in the concept, like to show that they're analytic in the narrow sense. He failed, but the option to keep trying to prove it stayed open. So this question whether Kant is right or wrong stayed open, because you can say, okay, I failed not because there's a inherent problem in the proposition, but because I just still didn't find the right proof to show Kant that he's wrong, that it's actually, this proposition is actually analytic. For instance, like 7 + 5 = 12. What you do get if you do this separation between the synthetic in the narrow sense and analytic in the broad sense is that you can say, okay, every proposition that can be redefined or redescribed or renamed as analytic in the broader sense maybe can someday be shown to be analytic in the narrow sense, but all the synthetic ones cannot. So somehow Maimon does a distinction that you don't have with Kant. I think it's interesting also for Kantians, not just to say, oh, this we understand, this we know, okay. And also to think more clearly what it means to do synthesis, because just to say unity in manifold, manifold in unity, I see why some people would not want to go further. But since there is so much going on about analytic philosophy, and I don't know, like Marco Panza is more from history of philosophy, history of mathematics. He has 18 different kinds of analysis. And when Bini writes about analysis, the history of analysis, you also have like 3-4 main ones and then different notions. I think it's also interesting to see this proposition, this type of propositions, and not just say, oh, they're all synthetic a priori. So I hope I answered your question. So the first is, I think he points at something that is not pointed by Kant, and I think that for him, he shows that a part of what he wanted to do in the first book cannot be done.
Yeah, thank you.
Great. Timothy, it's your turn.
Oh, great. Thanks. Those two last questions were very good, and my question is similar. But thank you for this. This is something I've had trouble with. Ampliative analysis. It seems like at first glance very strange, right? Because geometrical axioms determine a construction, which in turn determines a property. It seems that somehow necessarily is there, and so at least at first glance for me, it's sort of like, well, doesn't this then make Maimon just want to have better, more conceptually defined, more conceptually determinate axioms in the first place to account for those consequences? But with that in mind, then I'm wondering about his notion of geometric definitions or axioms in the new logic. What are they like? I'm hearing that they are synthetic, in some way synthetic a priori. But why? Why were they such at that point for Maimon? In connection with that, there's another remark in chapter 3 on concepts where he does a lot of this work, right? Where he says, oh, we have the concept of circle in higher and lower geometry, and the consequences of both are the same. So those concepts are what he calls reciprocal concepts. And so that's another puzzling remark for me. And I wonder, is there also ampliative analysis in higher mathematics for Maimon? In connection with my last question, is it something that's just for Euclidean geometry? And does that mean Euclidean geometry is in some way to be improved, or maybe not the best geometry? And then in turn, how does this all maybe relate to his logic, right? So he has a theory of thinking, which, probably corresponds to a new concept of the object of thinking. And then, might we go in that direction in response to those previous questions? But in any case, thank you very much.
Thank you. Thank you for the question. So with the circle, I think what he has in mind is you have a definition of a circle in Elements, which is the space, an equal space from. I don't remember the exact the definition, but it's something like the space that is in equal distance from the center, from one point. And then you have the postulate, which is how to construct the circle, which involves movement, which is a bit weird, but you have the also like the construction of the circle itself. And I guess what you mean by higher geometry, you have the formula that Descartes gives for in algebraic geometry for a circle. I don't remember now if it was like a power 2 plus b power 2 equals, that's, something
Probably.
like this. Yeah, and when you talk about analysis and mathematics and Descartes and everything becomes even more complicated, because also in mathematics there's a lot of fields called analysis. So calculus is analysis, and algebra is sometimes called analysis, like art of thinking and art of analysis. You have books by, I think it was Viette, it's about analysis. So also there you need to always think about, okay, what do I mean when I say analysis? If you say today in mathematical course, usually they think of calculus or like infinitesimal. And so what did you ask about these two differences? What can appliative analysis be there, or?
Oh yeah, I would just exactly. Is there this? I know exactly what that equation of a circle. You can do this. You can do this in Cartesian coordinates. Right.
Yeah, you just mentioned the consequences. I just remembered. Okay, I think what he means is that if you have the definition of a circle, or you have the postulate of the circle and you construct it, or you have the formula, which is, let's say, close to a mathematical definition, then all the consequences are the same. Like the pi would be the same, the surface will be the same, like all the properties you would find, and of course the distance of the point from the circle itself, the center, all the properties will be the same. All the propositions you have from the elements, they're not wrong. I don't remember now, like if you draw a line at this distance and a tangent and all that, then it's all still applicable if you look at it from algebra. So I think in this, the consequences are the same. And the second part about the logic and why Euclid. So I think here it's referred to what I said before. The connection is in the will to write about something that is given as actual in space or time, but here in space. And at the same time, the construction of knowledge for him is relation between propositions. It's even not the propositions themselves, because when he talks about invention in his commentary on Maimonides, he says the earth is flat is not a better or worse proposition than the earth is round. The only reason that the earth is round is we can consider it as more certain is because it's connected to many more other propositions that we have. And the earth is flat, we have less connections. So for him, there's a very big emphasis on the logical connections between propositions. So I think the Euclidean geometry, what it does, it gives him some kind of access between objects given in intuition and propositions. And if you take algebra, then it's a bit more, because he already knew algebra. He wrote a textbook by that time. I'm just doing a critical edition, volume, I don't know, 20, in what Katerina started. So he knew, or he knew at least for some extent enough that he could have written, and it made also more sense in a way to write a theory of invention about algebra. But I think it's exactly what Katerina said about the skepticism that made him use geometry. Thank you.
Okay, so I guess we should conclude the formal part here. But before we can thank our speakers again, I'd like to mention that on November 16, we'll have the next session of the Leuven seminar. And the speaker is Stefano Bacin, and he'll give a talk on Kant, titled "Not a Will of Any Particular Kind, Kant's Rejection of Universal Practical Philosophy." And the response will be by Natalia Polatnik. So yeah, I hope to see you again, either during that session or one of the future sessions. And let me now thank again Idit and Katerina for their wonderful talk and response. And please hang on for the informal part of this session if you have time. So Luis, please stop the recording.